Hot off the presses, the State of AI report. Let's get started. So here are the people behind it. They are part of Air Street Capital. Here are the team behind it. They list some definitions of AI, AGI, agents, GPUs, etc. We'll go ahead and skip those. Interestingly, they mention transformers in there. And the various multimodal input and output types such as text, image, code, software tool use. So these two are probably can be also thought of as APIs, API use. Music, video, 3D, creating 3D objects and images and drawings, etc. And robot state. This is likely, we're going to be talking about the RT2 from Google, RTX, as well as Eureka from NVIDIA, amongst many, many others. They had some predictions from 2022, and I would say they got a lot right. Definitely, it looks like more than half of them correct. The thing that struck me here is some of the ones that got correct, they were 10 times bigger in magnitude than what they predicted. So they said audio tools emerge that attract over 100,000 developers. And of course, there's 11 labs and Resemble AI claim over 1 million users. So that's a 10x over what they thought. GAFAM, so that's Google, Apple, Facebook, Amazon, and Microsoft, invests over $1 billion into AGI or some AGI focused company. And of course, 10 billion was added by Microsoft to OpenAI. And they thought that over 100 million will be invested in a dedicated AI alignment organization. Of course, Anthropic raised up to 4 billion. So that's a 40x. So this is 10x, 10x, 40x. The rest of these were interesting, but we'll actually dive into them in the paper itself. So for example, this 10 billion parameter multimodal reinforcement learning model, we'll talk about that more in the paper itself. So let's get started. In this video, we'll just mainly go over the research. So everything that's happening in the research and developments. Now, this is a big, big paper, so we're not going to cover a lot of it. But the main focus will be research to see where the heck everything is going. So let's get started. GPT-4 crushes everyone. So GPT-4 is trained on both text and images. It's multimodal now with Vision and DALL-E 3 coming out. Now, really fast here, they talk about RLHF. So really fast, we have to kind of explain what that means in terms of GPT-4 and why that's an important subject, basically really fast. So the base GPT model, when it comes out, it's a text completion model. So if you say hi, it might predict what's statistically likely to come after it based on everything that's read on the internet. So it actually might say something like greetings, hello, salutations, and just kind of like complete this because it saw that on the internet. But most of us are using the Instruct model, Instruct GPT, which has used reinforcement learning with human feedback. And that's those chatbots that we're aware of, ChatGPT, etc. If we say hi, it will actually answer us. It'll say, hello there, how can I help you? So just FYI, so when we're talking about the GPT-4 that we know and love, that has been made from the sort of base model with reinforcement learning of human feedback into that helpful chat assistant that we know and love. All right, so as you can see here, the green lines here is how much of an improvement GPT had over the blue lines, which is GPT 3.5. So you can see on various tasks, it's much, much, much higher. This whole improvement here is GPT-4 over GPT 3.5. And this success was largely due to RLHF, so human feedback, but human feedback is very expensive. It involves humans ranking language models' outputs to reward the human preferences. And of course, this is hard, expensive, and biased. It could be biased. And so a lot of other people are working to try to have some other solutions besides, involving humans in the training process. Now, some researchers have tried replicating the abilities of these large language models to basically imitate them by having the smaller models be trained by the larger, more capable LLMs. And it sounds like so far that hasn't been working out anywhere near as good as our LHF, the human reinforcement part, right? They say that the superior writing abilities of LLMs, even surpassing humans in certain tasks, are fundamentally driven by RLHF. So we need that human reinforcement, or rather reinforcement learning of human feedback to make it work well. Next thing is talking about how, perhaps driven by OpenAI, it doesn't disclose any useful information for AI researchers. So everything's becoming more and more closed. Google followed suit and Anthropic followed suit as well. So more and more, these companies are becoming closed without publishing their reports on Archive and similar websites where they generally publish their research so that everyone is able to read it and able to gain knowledge from it. And they're citing competitive landscape and safety implications as the two main drivers of that. The one LLM that's different is Llama. So Meta, aka Facebook, released a series of models called Llama. And they are kind of open source. They weren't in the beginning, So Meta initially granted access to Llama model weights only for researchers, but that was like immediately leaked to the whole wide world, making it kind of open source in a way. Later, Facebook/Meta said, we will not allow this to be used for commercial use, but people made a lot of noise. And then the second iteration, they made it open source. There are many other open source LLMs that are trying to follow suit. So we have the Stanford Alpaca, Vicuna or Vicuña, however you want to pronounce that. We have our Red Pajamas, right? So it's based on the llama architecture, right? Llama, red pajama, crying softly for his mama, etc. You know what I'm talking about. Then there's the Falcon, which is out of the UAE. But so far, it seems like Llama, at least according to this paper, is the most generally capable and publicly accessible LLM. Now, it does have limitations where you can't use it for commercial applications if you have more than 700 million users, which is not going to affect most people. This is basically telling Google and Microsoft and the rest of the big tech, well, you guys can't use it, but pretty much everyone else can. I mean, most of us will not be developing an application that has, 700 million users. Or, maybe you are, but I'm not. And GPT and Llama are the more popular ones online on X. RLHF, instruction tuning, that's the big conversation of the day. Noticeably, autonomous agents is also increasing, but the RLHF instruction tuning is the most trending topic since 2020. Then they mentioned the continuous debate about, the emerging capabilities of large language models. So we've covered this in a few previous videos that we've done here. Sometimes as we scale up, these new capabilities, new abilities emerge. And sometimes they emerge quickly and unpredictably and kind of unintuitively. So sometimes you'll see something be, near zero for a while and then rapidly go up to, close to 100%. We've seen that in other papers, and the researchers themselves have described that as being unpredictable and unintuitive. And of course, there's other people, for example, Stanford researchers say that that's not really a real thing. It might be a mirage that there are emergent abilities. Depending on how you measure these, it could be just a fluid and natural progression. But others are not convinced and offer counter arguments to the points below. So yet another thing that the industry or the AI research community is kind of split on, similar to whether or not these have mental models, whether or not they have reasoning abilities, etc. Then context length is the new parameter count. Now, of course, context length is the sort of the short-term attention of the language model, how much words it can remember at one time. So it's between the input that you give it, it's, maybe it's system prompt, as well as output. It has to be under a certain amount of words or tokens. And if it starts running out of space, well, it starts forgetting stuff. So that has been a bottleneck. So for example, if you have a large book that you want to upload to ChatGPT and you want to ask questions about the book, well, a lot of big books, it won't be able to sort of keep in its memory at one time. It will run out. Even large PDF files will be difficult to chat with, because you're going over the context length. And so context length has consequently been an increasingly important theme of research. And they're suggesting several innovations. They're talking about flash attention, length extrapolation, rope, and positional interpolation. And so like the biggest long context LLMs right now is Anthropic Claude with 100K tokens and OpenAI GPT-4 with 32K tokens. Some of the researchers have found that the model's performance was better when the relevant information to the task you're giving it occurred in the beginning or the end of the output with a dip in the middle. So if you give it 20, documents, it tends to remember like that first one pretty well. And then there's a dip here in the center. And then towards the end, it increases again slightly, which is probably very similar to how humans memorize things. And of course, the model's performance decreases as input length increased. So again, interestingly, kind of similar to humans, like the more stuff you have to memorize, the less you will actually memorize. Microsoft found that small language models that can be trained with very specialized and curated data sets can rival models which are 50 times larger. One hypothesis is that the small models aren't as good as larger ones because they're overwhelmed when trained on very large curated data sets. So for example, here, they've generated something called tiny stories. So it's just supposed to create little stories that capture English grammar and general reasoning rules. And they found that those stories that the small language model created was preferred to the much, much bigger GPT-XL 1.5 billion token model. So for that one particular use case, the much smaller model was better than the much, much, much bigger model. And also it looks like the same thing can be applied to producing high quality code for specific tasks. Now, you might remember this meme that was floating around. At some point we thought, well, this is GPT-3 and then GPT-4 is this massive, massive thing that's coming out. Now, keep in mind that this is kind of rumors and hearsay. Some of it is based on leaks that happen and some of it is based on people's sort of, maybe not gut feelings, but they're kind of like researched opinions. So this isn't confirmed, but this is kind of what a lot of people believe, is that GPT-4 is working with something called a mixture of experts. So it's not really one model. It's a collection of models. Here they're saying a 16-way mixture model with 8 sets of weights. I think I've also heard that it might be 8 different models or 6 different models. We don't know, but it's multiple models that maybe each are maybe a little bit larger than GPT-3 was, but they kind of work together in tandem to create the results that we think of as GPT-4. If this is to be believed, that there's no fundamental innovation that underpins GPT-4. It's just using the same technology and kind of like hooking it up to each other in a certain way that makes it much, much better. Are we running out of human-generated ideas? So some research from Epic AI says that, if we keep going at this rate, we're going to exhaust our human-generated data, our text and our pictures, etc. Now, there's some innovations that might challenge this, basically saying that things like OpenAI's Whisper, they can transcribe a lot of the audio data, providing much more data that we can use. There's new character recognition models, OCR, like Meta's Nougat, that might allow more data to be sort of processed by these LLMs, these models. And even if that's not the case, we have AI-generated content that we can train the models on. So that's something that's referred to as synthetic data. Basically, we start with taking a bunch of pictures that humans made, we feed it into a model, and then it starts producing images that are, let's say, as good or almost as good as the human-produced images. So what happens then if we take that AI-produced data, the synthetic data from these AI generation, and we feed it back into itself? Is that good? Is that bad? Because that would basically make it unlimited. The volume would be only bounded by compute, by how much, computing abilities we have. Now, people warn that, there could be compounding errors. So since the AI generated data is not quite as good, there might be errors, there might be if you've ever seen those AI models make hands every once in a while, there's like a 6th finger sticking out or something like that. So oftentimes fish might have an extra eyeball somewhere. So over time, if we keep feeding these slightly off images to a image model, for example, these errors will compound and eventually, the model might collapse. Generated data ends up polluting the training set of the next generation of models. Now, of course, the answer to that could be just carefully controlled data augmentation. So basically making sure that there's not too many of these errors. And then researchers from Google did find that using synthetic data to train their AI models, it does show sort of a even and smooth increase in the model's accuracy. So as we give more data, it increases, it improves. So overall, this seems pretty positive for synthetic data for AI generated content, but we will get more information about it as we start using it more and more. Is it going to collapse like it says here, or is it just going to be a continuous smooth improvement? We have yet to see. Disentangling the real and the fake. So basically, it looks like the interesting thing here is that Stable Diffusion, the open source AI image generation, looks like it memorizes individual images from training and emits them at generation time. So if you look at this image right here, they're pretty much the same, right? So it's the same face, the same necklace, the same earrings, the same exact suit with the same exact angles of the blouse, right? The backgrounds are the same. Here's that wall. Here's that wall. There's some sort of a wall behind here, some sort of a grassy area here, right? Maybe the sky over here. They're pretty much identical. It almost looks like maybe this one like added some wrinkles, it almost looks like, but it's other than that, they're pretty much the same. And so this is the generated image. This is the training set. This is the original image. And so, this is not great for sort of all the lawsuits that are happening with copyright infringements by these AI models. So that's something that we have to keep in mind. But more and more companies are trying to find a way to watermark images and also to find ways to identify generated images, as well as try to maybe encode some sort of a hidden pattern text so that while we can't read it as humans, we'll be able to identify in synthetic. This just sounds to me like a really bad idea because, the question is, first of all, is it possible to do that? And would it be easy to get around it by using, let's say, another model to rewrite it? And also, is this going to make the outputs worse? right? If it's not focusing on just producing the best text, but it's trying to produce a text and try to like work in some hidden pattern in there, this just seems like it's going to drive the results down. So I'm not too happy about this, but we'll see how it works out. My guess, I'm going to make a prediction right now. This is going to be a dead end. This is not going to work. Next, they talk about overtraining. So basically, when we're training, let's say we have this much data and we start the model training on it. So we go through it once. And so now it went through the entirety of this data once, and that's called an epoch. We can just start it over and have it go over it again one more time, right? So that would be 2 epochs. And they're saying that training for 1 or 2 epochs will generally be optimal for most things. However, there's a few cases where pushing for a few more epochs can help. So basically having it go again and again and again and again. But too many epochs generally equals overfitting, meaning that it might be good at solving everything that it sees in its training set, all the data that's been fed, but it might be not as good at solving unseen tasks, which kind of makes it maybe not useless, but certainly not as good as it's supposed to be. Basically, it won't be able to do anything novel or new or general. It's just what it's been trained to do. This is basically saying as a vibe check, while there's a lot of benchmarks for these LLMs, most users still kind of follow their gut, follow their vibes when picking out which one's the best. All right. So if you're looking on X/Twitter, users tend to disregard the leaderboards provided by Helm and Hugging Face, etc. Kind of trust their vibes when they're applying LLMs to their specific use case. Then we look at the state of LLMs for code. So the leader in code is, of course, GPT-4. They have things like Code Interpreter. That's now called Advanced Data Analysis, as well as some other systems like AutoGen by Microsoft, which uses GPT-4 with an extra infrastructure that can create some amazing things, as well as ChatDev. There's many different ones, but kind of integrating GPT-4 into a multi-agent structure can create some really good things for coding. Here they also mentioned CodeLlama, as well as some smaller LLMs that are both low latency and good performance on code completion tasks. We've talked about this. AlphaZero is DeepMind's gift that's able to optimize low-level assembly code. We've had a video on this. Basically, AlphaZero, so that's that AI that's able to beat everybody. It's superhuman. It's beating everybody in chess and Go and Shogi. They basically made writing low-level assembly code into kind of a game where AlphaGo takes turns writing out code. So it's line 1, or line 2, line 3. And eventually it did this one line where that looked very alien, very bizarre. When the researchers looked at it, it was like, oh, is this a mistake? Did it mess up? But in fact, it optimized this assembly code, which led to improvements for certain sequences, which is kind of a big deal because of how often this low-level assembly code gets used. So things like this can be a big deal because AI can have this superhuman patience to just sit there and try different stuff out that can have big effects on the various machinery and computers that we use. And they also mentioned here that somebody managed to make GPT-4 come up with a similar optimization. Then we're getting deeper and deeper into prompt engineering. Of course, the quality of the prompt influences task performance, right? So the most standard is input-output. We ask it a question, it gives us an answer. Then we have chain of thought. This is where we either ask it to think through everything step by step, or another way to approach this would be to break a complex prompt into multiple steps and just feed it one step at a time. That tends to improve the results. Then we have self-consistency, where basically we ask it to produce the output multiple times. And in this case, we do it with chain of thought, but we take a look at the conclusion it reaches each time. And so if it gets, one answer most of the time, and then another answer, like a small portion of the time, the one that gets most of the time is probably the correct one. So this improves the accuracy. Then we cover tree of thoughts, where basically we have to think through certain branching thoughts, branches of thoughts, until finally coming up to the correct solution like this. This was very effective with crossword puzzles, for example, where you have to, place a word and then see if it matches up with all the other clues and stuff like that. So things like this optimize accuracy and performance. And here they're saying there's also things like automatic prompt engineer, where the model itself comes up with prompts to test which ones are better. Then there's optimization by prompting that outperform human design prompts, sometimes by up to 50%. Now, of course, this is pretty cheap, right? This is the cheapest alternative, like question, answer, that's it. Whereas something like this, there's so many different outputs that happen this is going to be much more expensive to run. And I assume things like this are more expensive still. This is talking about how GPT-4, the performance dropped over time, it seems like, whereas GPT 3.5, the performance improved. But basically, they're saying that there is a noticeable difference between March 2023 and June 2023. And then LLMs are learning how to use software tools. So here they're talking about this thing called Toolformer by Meta, where it decides which APIs to call, when to call them, what arguments to pass, and how to best incorporate the results into future token predictions. And, things like this, they say, is the most immediate way LLMs can have an impact on the economy today. I mean, the most obvious ones, and we've talked about this, is just using a web browser, being able to jump on the web, do a search, open up Excel, just basically anything that a human being can do. If the LLM can do that on a browser, on a desktop, that would be huge. And of course, even the next step would be able to use, API calls to use virtually any tool imaginable. They mention AutoGPT and Baby AGI, but of course, there are many other ones. Open-ended learning of LLMs. Of course, they're talking about Voyager, our Minecraft agent that runs around the world of Minecraft, learning and reasoning, exploring, acquiring skills, and saving those skills into a library that allows it to improve. So this blue line is this AI without saving those skills to your library. Eventually, it plateaus. It stops improving. But with the full architecture, with the library, it just keeps going and going and improving and unlocks key tech tree milestones up to 15 times faster than the previous state-of-the-art models. And it does use API to build those skills. It uses GPT-4 as its reasoning engine. It produces code with this API. And if that code works, that new skill works, then it adds it to its database. And then reasoning with a language model is planning with a world model. So this is interesting. So they said reasoning has been traditionally thought of as searching a space of possible outcomes and picking the best one. That's an interesting definition of it. By containing so much information about the world, LLMs offer the opportunity of generating the space, often called a world model, in which planning algorithms can explore. Reasoning via planning, RAP, uses Monte Carlo tree search to find high reward reasoning paths efficiently. So this is yet another step past things like chain of thought and tree of thoughts. Here we see that, while RAP is more expensive, so this model, this reasoning via planning, it's more expensive, it outperforms chain of thought reasoning. For example, on a Llama 33 billion model, it outperforms chain of thought on GPT-4. So this is pretty big. We will need to look at this paper in detail in one of our next videos because this is looking very interesting. GPT-4 outperforms reinforcement learning algorithms by studying papers in reasoning. So normally when we're playing games like Minecraft, Crafter, various other games, with reinforcement learning, it kind of gets rewards by randomly mashing buttons, and over time it figures out the best paths to take. But GPT-4, you can give it the manual, you can give it the academic paper, and then it plays the game through an LLM, which is a little bit similar to what they did with Minecraft, because Minecraft has so much data, and they fed it some more data when they were prompting it. They told it, here's how you write API calls, here's how, here's some ideas for how to progress, etc. So they told it in a prompt how to be better at Minecraft, and it did that. So this is similar where you give it a paper and then it goes forward and starts, taking action in the environment. So here they talk about GPT-4 with vision basically being one of the better ones. There's some other ones. Llama has their own. There was Blip 2 from Salesforce, but it seems like GPT-4 is the best right now, even though the API right now, as of the recording, we don't have the API access to GPT-4 with vision. So we can't have it just look at images with API. You have to, upload it to ChatGPT, the browser mode. Then we have leveraging LLMs and world knowledge for compositional visual reasoning. So for example, we can plug in something like this and say, which pet is in the top left, right? So this little doggy there, and then it's able to think about it. It looks like it's using some sort of Python code, and it says, okay, so that is a Shiba Inu. And so this visual programming approach, it aims to build general purpose vision via compositional multi-step reasoning instead of end-to-end multitask training. And world knowledge in LLMs from training on internet scale data is shown to aid in visual reasoning tasks. So we've seen this with the Google robots. They're trained on internet scale data. They read the internet, so to speak, to become better at following commands, picking up objects, and understanding how to work in the real world. Here we used our large language models to sort of think through what they're doing for autonomous driving. So as they're driving, they'll say, I'm overtaking a vehicle that's parked on the side. So they're explaining what they're doing. I'm remaining stationary as the lead vehicle is also stopped. Palm E is a foundation model for robotics. So this is Google and their RT2 and RTX robots, which have been very exciting to read about. So they're getting much better at general object manipulation and figuring out how to do tasks that are novel, that they haven't seen before. They're able to improvise. In one of the tests, they were asked, okay, find something in this room that can be used as a hammer. And there wasn't a hammer in the room. So it picked up, I believe, a boulder or a rock of some sort and said, we can use this as a hammer, which is very smart. A little bit scary, but very smart. And they're talking about RT2. That's exactly what I was talking about right now. So from vision language models to low-level robot control. So the big breakthrough, I think, with the RT2 was the fact that they use an LLM to pilot the robot. So they take an LLM and they put it in the robot and they tell it, okay, you pilot this thing. And the results are very, very good. Internet scale training enables generalization to novel objects. Oh, figuring out what object to pick as an improvised hammer. This is exactly what I was talking about. So this is directly out of the paper that we covered on this channel. So it's very good at figuring out what you want. So sometimes you don't even have to tell it what object to bring. You can say, I'm thirsty. And it'll go to the fridge and it'll find, whatever is in there to satisfy what you asked for. So it might bring you a Gatorade, for example. You can say, I'm tired, and I'll bring you an energy drink. And of course, somebody created something called the RoboCat, because of course they would create something called the RoboCat. Looks like it's built on top of DeepMind's multimodal, multitask, and multi-embodiment Gato. Gato in Spanish is cat, therefore RoboCat, of course. And it looks like this is used for various, more manufacturing and conveyor belt and stuff like that. And RoboCat can operate on 36 real robots with different action specializations, with different action specifications, 253 tasks, and 134 real objects at an impressive speed. I'd love to see videos of this. Google DeepMind is killing it in the space. It's really good to see. You might have seen this before, the autonomous system that races drones faster than human world champion. So it's a first person, you put on this little mask and you fly the drone through various obstacles through the course, and surprise, surprise, AI is better, or at least now it's better than humans were. And it looks like they train it in simulation, and the policy transfers well from sim to real life when accounting for uncertainty and perception. This was the big breakthrough that a lot of people are working on right now with NVIDIA and Google DeepMind. They train robots in these simulations, then they bring them out to the real world, and they do exceptionally well. And I think this is one such example of that. The emergence of maps in the memories of blind navigation agents. So it looks like when we ask blind agents to navigate various physical environments, they build sort of a mental map that's an emergent phenomenon as they learn to navigate. And their accuracy is as good as sighted agents. The success rates are equal. Now, efficiently, it says only efficiency differs, which I take to mean that the blind agents are probably slower. It probably takes more time for them to figure out how to get there than a sighted agent, but they tend to get there, at similar success rates. And it's possible to reconstruct those maps that those blind agents create in their mind, so to speak. So we're able to reconstruct those maps, which is very interesting to think about. I mean, you take something they can't see, you let it learn how to navigate a maze, and then you're able to extract the map of that territory. Cicero masters natural language to beat humans at diplomacy. So diplomacy is a very popular multiplayer strategy game. So you have to plan and negotiate in natural language. I believe you're playing on sort of like a world board, and you're a different nation. So kind of like Risk, but with more, diplomacy, with more talking. And so Cicero uses dialogue history between players as well as the board state in its history to predict what everyone will do. Then it iteratively refines these predictions using planning, then decides according to a policy which action it intends to take. I saw some videos about it doing this, and one thing that was very interesting is it will try to convince other players to take out its opponents on its behalf, but it doesn't do it in a blunt way. It kind of says, well, hey, John, you see Bob over there, Bob in Poland? Bob in Poland looks like a threat to you. You have such a powerful army. Shouldn't you maybe take Bob out? That's probably going to be good for you, right? So it convinces them to attack the people that it wants you to attack. So I don't say tricks them, but it's very manipulative, cunning. It's good at diplomacy. Very interesting thing to watch. Then we have more and more text to video. We're having things like this, which aren't even video. It's some sort of an animation, fancy landscape animated oil on canvas. I think once this gets really good, the the things that you'll be able to create will be only limited by your imagination, because the AI will just bring it to life no matter what you describe. If you ever wanted to learn Photoshop but just didn't have the time, this is interesting. So it's instruction-based editing assistance. So you take this image of sunflowers and you say swap sunflowers with roses, and it does that. What would it look like if it was snowing? Here we have add fireworks to the sky, turn Woody, what's his name, from Toy Story into a Western. Then there's this, I believe this is pronounced Gaussian, 3D Gaussian splatting. So basically creating 3D sort of spaces from 2D images. So this is from image to a 3D space. If you've seen examples of this on Twitter, this looks incredible. People take pictures and then you're able to see the 3D space. This is more of the same, where basically we can rapidly create 3D images, 3D models from either text or just pictures, and we're able to do it quickly and at scale. Then there's more about video, weather prediction, music generation. Then we have various molecular specifications. We have protein structure, predicting the outcome of various genes, pathogens. And then we have Google's MedPalm 2 being incredibly good at answering medical questions, better than a lot of physicians. So it's getting to the point where this chatbot is maybe preferred by people to talking to a doctor. And of course, MedPalm is going multimodal. So we're going to have images. For example, if you have x-ray scans, it can look at them and maybe answer some questions about it, etc. TweetStorm, so there's state-of-the-art sort of pre-trained model from medical Twitter, and many, many more. There's a lot more AI in science. And it's also showing that the most impactful research comes from very few places. So as we can see here, USA is number one in terms of the amount of research that it puts out. China's over here. So it's number one by quite a big margin here. China's number two. UK is number three. And Singapore is number four. Singapore is definitely punching above its weight for being a much smaller country. I mean, this is, US and China and UK. We're talking about Singapore's smaller and it's still up there. It's, competing with the giants. In terms of institutions, we have, Google, Meta, Microsoft. Then we have some US universities. We have DeepMind, OpenAI, etc. Tsinghua University here from China. NVIDIA is there as well. National University of Singapore, etc. All right, next we get into the industry. We're going to skip a lot of this because this is just basically about talking about how incredible NVIDIA is doing, how in-demand GPUs are. Is compute the new oil? Who has the most compute? Meta has the most A100 clusters. Google has the most H100 clusters. NVIDIA chips are dominating. NVIDIA chips are very good and they last a long time. While NVIDIA is king, there's other ones. Cerebras in this case is the one that kind of takes a big jump. It looks like Microsoft is spending almost 15% of their total capital expenditure on AI. So it's definitely putting a lot of money into AI. Tesla is building up more and more of their compute clusters towards the top 5 largest. US prevents some of the higher GPU models from being exported to certain countries, for example, China. In response to that, NVIDIA and Intel, they're creating smaller chips like the A800 and the H800, which are designed to be below the threshold so that they're able to be exported. And of course, there's tons of money that's being poured into generative AI. A lot. Coding AI assistant drives productivity. ChatGPT drives productivity for certain types of writing, boring writing. And of course, there's these AI chatbots, AI girlfriends, whatever you want to call them. They're gained significant traction, but it does sound like the retention and the daily active users aren't as big for those AI companies as, for example, YouTube or WhatsApp, etc. Or even, I would say it's on par with Candy Crush. So, yep. Midjourney, that's my favorite AI art generation tool. So it looks like it reached 1 million monthly recurring revenue in March 2022. And it looks like it's on track to hit 200 million annual recurring revenue in 2023. I like Midjourney. And here they're saying, have we reached peak regulatory divergence? So it looks like here are the the countries relying on existing laws and regulations. And then also introducing AI-specific legislative framework. So that's UK, Canada, US. So it looks like it's relying on some existing ones and it's introducing some. And here are some that are banning specific services plus introducing new ones. So China. There's some that are just banning certain ones like ChatGPT. And these, interestingly, are relying on existing laws and regulations. Now, I know that Japan, I do think they introduced something towards saying that AI models that are for art do not infringe copyright if you're training your AI model on the pictures out there, that's not infringing on copyright. So I think they introduced that one, but I think they're taking a pretty forward-looking stance on AI.
That's it for today. I think we covered the most important things on there. Hope you enjoyed that. See you again soon.